Welcome to the next session on the Seaborn library, and shall be initiating our discussion on the bar plots. Now, bar plots are again very interesting type of plot. They are categorical plots. That means one variable has to be of categorical nature, and bar plots displays the mean of quantitative variable per category. Like for example, if you can see the these bar plots, these black lines, these are known as error bars. Now, these bars basically are displaying the mean of every of the quantity variable per category. Like Thursday is one category, so the mean of total bill for Thursday, mean of total bill on Friday, mean of total bill on Saturday, and the mean on Sunday. So this basically this is extended because it is showcasing the 95% confidence interval level. Now that simply means that the mean value lies this somewhere between this interval. All right. So if this bar is longer, then that means there is a lot of uncertainty in our estimate. The shorter the bar, that means the level of uncertainty is automatically low. So again, I will use the catplot function x day y total bill data df and kind is equal to bar. So this is what I will get. If you don't want to see these error bars, now this option is not default in Matplotlib. In Matplotlib, you don't get the error bars by default. So if you want to remove error here, you will get error bars by default. If you want to remove them or if you don't want to show them, then you have to mention this ci equal to none parameter and the bars will be gone. Then if you wish to change the orientation, that means vertical to horizontal plotting, then you have to simply change the x and y values. So total bills which was earlier taken as x earlier taken as y will be taken as x, and days which were earlier taken as x will now be taken as y, and it will give you horizontal plot. Later on, when we'll go onto the bokeh library, the advanced version, then you will see that you don't need to do that in bokeh. Bokeh provides you options for both horizontal and vertical bar separately. Then we have the box plot, very interesting plots which you can see in front of you. Now this they show the entire distribution of the quantitative data. Again, the variable box plot is also categorical type of chart, so one variable has to be of categorical nature. So now what it represents. Now these dots which you are saying, which you are seeing, these are outliers. That means the values which are beyond our data set, some outliers which we don't know the reason as such. Then this is the minimum value of data set. This is the maximum value of the data set. This is the 25th percentile value. This is the 75th percentile value. And this is what is known as your median. This is what a single box shows. Box plots are very common if you try to understand the or if you're trying to understand the seasonality in your data, whether seasonality is present in your data or not. For example, in a time series, if you want to see whether there's a seasonality or not. Seasonality means that or in a particular season, in a particular time period, the movements are fluctuating a lot. So if you want to analyze the seasonality of the data, then box plots can be used. And this is what the box plots represent: the median, the spread, the skewness, and the outliers. So skewness will help you, or the distribution helps you understanding the distribution of the data and to understand whether seasonality is present or not. So again, it facilitates the comparison between groups by showcasing some critical variables to us. To prepare a box plot is very simple actually. You just have to replace kind with box instead of bar or count. And if you want to order of category, that means, for example, here lunch has been shown first, the dinner has been shown from. If you want to change the category, you can have order function here. Order is equal to, you can place dinner first and the lunch later on. Little bit an additional parameter that you have to introduce, and then you can say in your diagram the dinner will be placed first, the lunch would be second. That's how we prepare the box plots. Very simple, isn't it? That's what the learning is all about, making things simple. And there is there is if you make the thing learning difficult, it's become very difficult to grab it, to use it, to implement it. You might learn, but you might not be able to. The motto of this course is to make you learn as well as make you improve. If you want to omit the outliers from the plot, you don't want to showcase these outliers, these dotted areas outside the plot, then you have to use the sim function. So just add one more parameter, which is sim equal to, and then double quotes, and the outliers will be vanished. Simple. You can change the default whiskers as well. Like for example, these are the default whiskers showcasing the minimum, maximum, median, 25th percentile, and the 75th percentile. If you want to customize it, you want to change it, increase it, you can do it. So by default, whiskers extend to 1.5 of the interquartile range. This is basically the interquartile range, the median, what we call as. So by default, it is 1.5. They can extend. They extend by default. That's the default value. You can extend them to two times of it. So you have to specify vis equal to 2 if you want to do that. If you want to show the fifth and the 95th percentile, then you have to mention vis 5 and 95. So it will showcase the fifth and the 95th percentile value instead of 25th and 25th. Or if you wish to show the minimum vaccine values, then you have to mention 100. So this is what you need. So here I have mentioned the sim parameter. So because of sim, outliers will not be shown, and with 0 and 100, so it will show me the minimum value and the maximum value in that. So you can customize your whiskers accordingly if you wish. So before we move ahead with the point plot, let's visualize the the bar plot. So bar plots are simple, like okay. So if you want to plot a bar, so when you plot a bar, this will automatically give you the error bars. If you don't want error bars, then you have to mention an extra parameter, which is ci equal to none. Run that. In the first case, the bar are there, which is showing the 95% confidence interval. If larger the bar, that means the uncertainty is high. And if you don't want to show the error bars, then you can have the parameter ci equal to none, and the bars will be gone. Then for changing the orientation, you have to just replace the x with y values and vice versa. And uh, sorry, our data is not tips, it is actually df, what we have taken. Yeah. So you will get a horizontal plot instead of the vertical one. Then we have discussed the how the box plot works. So in box plot, you have to simply mention the kind equal to box parameter, and it will give you a by default order of your categorical variable. If you want to have a specific order, like I want to place dinner values first and the lunch values later on, so I can specify that order parameter, the cat plot function, and this is what I get. So in the first case, the box plot, the lunch is first, the dinner is then after that. And in the second case, since I have specified dinner values to place first, I can see the box plot here. The dinner values are first and the lunch values later on. If you want to remove these outliers, then you have used the sim functionality. So which is the double quotes, and run this, you'll find that all your uh, outliers are gone. Okay. Finally, you want to change the whiskers. So 0 and 100 will produce the minimum and the maximum value. Place 5 and 95, it will place the fifth and 95th percentile value, and so on. So you can customize it to whatever extent you want. There are certain, though there are certain limitations to it. This is how it can be shown. Okay, so that's the whisk parameter that you have to particularly use. The next we come to what is known as the point plots. Very different kind of plots that we can talk about. Now point plots basically show the mean of the quantitative variable. Again, the x has to be categorical variable, because again it's a type of categorical plot which we are discussing about. So x is smoker here, that's the categorical variable. Y is total bill. So these points will show the mean values of the quantitative variable. That means mean value of total bill for smokers, mean value of total bill for non-smoker. Lines will again show the 95% confidence interval. That means our mean value lies somewhere here. And so if you try to differentiate between the point and the line plot, then both show the mean and the 95% confidence interval for the mean. But the difference is that land plot has a quantitative variable. That means x and y both have to be of quantitative nature. In point plot, the x-axis has to be of categorical nature, cannot be a numerical, because point plot is a categorical plot. It's not a numerical or the quantitative plot. So the same goes for bar. You can see just a for the purpose of visualization, you can see how you can differentiate between the point plot and the bar plot. The bar plots with the error bars, which you can remove if you want, and these are the point plot. This interval shows that mean values lies somewhere in this area, and if this error bar size is greater, then that means the uncertainty is high. Point plot is different. Point plots show the mean value of the quantitative variable, and again these are the 95% confidence interval values. Then this is how we can plot. So instead of again the cat plot function, the cat plot function using, and x values data, and then this time you have to mention kind equal to plot. Now there's a automatic join that is happening. This is the by default show. If you don't want the points to join, then you can mention the parameter join equal to false, and then you will get this type of plot. Okay. Then other type of customization that you can do, you can display the median. Uh, Display the median. You have to introduce one more parameter, which is estimator equal to median, the cat plot function. Rest of the all the things remain same. There is no change in that. Except that you have to make another import, which is since you are showing the median is an estimator here, so you have to import the numpy. From numpy, you have to import the median function. You can customize the cap as well. So to customize the cap means if you see here when you are drawing the point plot, the caps are not there. Want to show the caps, then you can mention the cap size parameter. Okay, and if you don't want to show the caps, then you can mention ci equal to none, or you don't want to show this intervals actually, not the caps. Caps are not there by default. You have to mention the cap size if you want to show caps. So instead of that, if you want to turn off the confidence interval, you don't want to show these confidence interval, you just want to show the mean points, then you have to mention the parameter ci equal to none within the cat plot functionality. So before we go into changing of plot styling and color, let's discuss this. So this is what I want to do. I want to introduce a point plot. So in the cat plot function, I have to introduce one more parameter. And if I want to remove the join, uh, then in that case, I have to mention the parameter join equal to false. So if I run this, this is the by default what we will get. And this is the scenario when I have referred or I have added join equal to false. The mean points will not be joined. Then here I want to display the median, that what I wanted. So display the median, I have to uh, use estimator median as well, and I have to make one more import, that is from numpy. I want to import median. That's very important. Otherwise, it will showcase the error to you. And if you run this, and that's what you get. Okay. So first scenario where it's a simple point plot. Second scenario where you are basically adding median as an estimator. So if I see the difference in plots, this is the scenario when the median is not has not been added as an estimator, and this is the scenario when median has been added as estimator. So now it is showing the median values. Earlier it was showcasing the mean values. So by default the estimator is mean. If you want to change the estimator from mean to median, then this is what you get. Then customizing the cap, which I told you that you have to introduce the cap size parameter, which is 0.2. Want to remove the confidence intervals, then you have to mention ci equal to none parameter, and run this, what you get. Okay, so first case, which is cap size, so the caps have been reduced here. And second case, sorry, there's error because our data is not equal to, let's run it again. Yeah, so now the confidence intervals are off, only the mean values are shown. Mean values for the people who are smokers, the mean value for the people who are not the smokers. And now we come to what is known as changing the plot style and the color. So you can change the figure styles as per your requirement, which includes the background and the axis as well. So the options which are there in the Seaborn library are white, dark, white grid, dark grid, and the text. So you have to use this function sns.set_style want to change the plot style. Okay, this is what we got. So by default, the figure is white. Any figure, the background is white. So by default, it is the white plot styling that we are using. You can use any other whatever you want. Okay, so you have to simply call this. Suppose I want to use white grid. So I have to call this function as this.set_style equal to white grid, and this is what I get. Instead of white background, you will get a white grid background. So similarly, you can use dark grid text. So I just, I want you people to actually work on it and see how the styling matters and differs according to the plot style that you're using. So make a quick. So the plot style is white by default. That what we have been showing and we have been doing so far. So that's a white background. If you want to change, then this is extra functionality that you have to go for, that is sns dot set underscore style white grid. So if I do that, this is the difference what you get. It's very easy. As well, you can go with dark grid text and so on. So this is where this session ends, and I expect all of you to be practicing good, practicing hard, and take full benefit and utilization of. Till that time, we'll meet in next.